What is a sandwich complex? The discovery of ferrocene, the most famous sandwich compound, is considered to be a historic landmark in organotransition metal chemistry. In 1951, ferrocene was discovered by two groups, Kealy and Pauson, and Miller, who proposed a sigma-bonded structure. The next year, Wilkinson, Rosenblum, and Woodward advanced the correct pi-bonded sandwich structure. While the organometallic works of Zize, Frankland, and Grignard predate the isolation and structural authentication of ferrocene, metallocenes and sandwich complexes hold a privileged position in the historical development of organometallic chemistry as they fundamentally revolutionized our understanding of electronic structure in coordination compounds. The introduction of ocene as a suffix for metallocenes can be traced to one of the flurry of papers surrounding the final identification of ferrocene, a new aromatic system. Woodward and co-workers stated, "We now wish to record experiments which demonstrate typically aromatic properties of this unique iron compound, for which we propose the name ferrocene." The chemical similarity to aromatic hydrocarbons gave ferrocene its name, and this convention stuck. However, despite the undeniable similarities between both the Texas toast depiction of C5H5 and the sandwich, this analogy was not made until the following year in Bis-Cyclopentadienyl iron, a molecular sandwich. Clearly, a sandwich complex should bear some resemblance to a sandwich, structure types that plausibly fit this description, and for which examples are known. For definitions of metallocene and sandwich complex, we can turn to the IUPAC Gold Book or the more recent Red Book. The International Union of Pure and Applied Chemistry, or IUPAC, defines metallocene as BeEEL cyclopentadienyl metal, like ferrocene, with parallel rings, while a broader sandwich complex involves a metal between two parallel rings, which can include non-CP ligands, but the term -ocene is often used loosely for related compounds. IUPAC definitions from Gold Book/Red Book. Metallocene, a discrete molecule often of the formula MCP2, where CP is a cyclopentadienyl ring, with essentially parallel cyclopentadienyl rings and a D-block metal. Sandwich complex, a compound with a metal atom between two parallel or nearly parallel ring structures, which can be carbocyclic, like CP, or other planar systems. The entry for metallocene informs us that the term should be confined to discrete molecules of the form BIES, cyclopentadienyl, metal, and ring-substituted analogues, where the cyclopentadienyl rings are essentially parallel, and the metal is in the D-block. Thus, of the sandwich structure types, only the C5H5 example would formally be a metallocene. Conversely, sandwich complexes are given as compounds in which a metal atom is located between the faces of two parallel and planar, or nearly so, ring structures. This is gratifyingly broad, covering the plethora of motifs. There are three general categories of mononuclear CP transition metal complexes. 1. CP2M, symmetric molecules with mutually parallel cyclopentadienyl rings. Such sandwich compounds are referred to as metallocenes. 2. CP2MLX, bent metallocenes, in which the number X of unidentate ligands L varies between 1 and 3. 3. CPMLY, half-sandwich, compounds in which the number Y of unidentate ligands L varies from 1 to 4. The archetypal organometallic compound ferrocene is of historical importance since its discovery and structural characterization in the early 1950s sparked extensive research into the chemistry of metal sandwich compounds. Two of the chemists who first proposed the correct structure of ferrocene, Geoffrey Wilkinson and Ernst Otto Fischer were awarded the Nobel Prize in Chemistry in 1973 for their pioneering work on the chemistry of sandwich complexes. Ferrocene is an example of a pi complex in which interactions between the d orbitals of the Fe2+ metal center with the pi orbitals of the two-planar cyclopentadienyl ligands C5H5 form the metal ligand bonds. Thus, all the carbon atoms in the cyclopentadienyl rings are bonded equally to the central iron 2+ ion. Ferrocene exhibits aromatic properties and is thermally very stable. It is also resistant to acidic and basic reagents. Preparation of ferrocene is normally a two-step synthesis. First, prepare freshly distilled cyclopentadiene C5H6, and second, use it immediately to synthesize ferrocene. Monomeric cyclopentadiene C5H6 dimerizes rapidly at room temperature to dicyclopentadiene by a Diels-Alder reaction. Thus, commercial dicyclopentadiene is thermally decomposed, cracking process, to obtain cyclopentadiene by fractional distillation. Freshly distilled cyclopentadiene was then reacted with iron 2 chloride in the presence of a base such as potassium hydroxide to get ferrocene. Crude orange ferrocene was collected and dried in the air and purified by sublimation to obtain orange crystalline material. The reaction and purification steps can be monitored using proton NMR spectroscopy. Ferrocene's unique sandwich structure, stability, and reversible redox properties lead to diverse applications, including fuel additives, anti-knock agents, catalysts for organic synthesis, polymerization, oxidation, advanced materials, polymers, liquid crystals, nanoparticles, sensors, glucose, heavy metals, and promising medicinal agents, anti-cancer, antimicrobial drugs, showcasing its importance in chemistry, energy, and medicine.